everyone. Today I will be going through part 2 of variation and selection. If you have not yet watched my first part of this chapter, please make sure to watch that. And if you like my videos, please don't forget to subscribe my channel. So looking into this chapter, the first thing that we'll look into is adaptive features. So adaptive features is one of the most crucial features required in any living thing in order for them to survive and reproduce, so that their future generation can also survive easily. Okay, so the definition of adaptive features is that it is an inherited feature that helps an organism to survive and reproduce in its environment. Some of the example over here. Okay, so the first example is camouflage. Camouflage is when an animal or a plant, you could say, matches with its surroundings so that it can't be seen. Okay, so it matches with its surrounding. Okay, now example is polar bear. Since polar bear are known for living in cold environments and in snowy places, we know that a polar bear is also white in color. It's pure white. And why is it like that? It's so that it can be mixed with the snow and it can't be really seen easily by anyone. Okay, so that's like one of the example of camouflage. And obviously we know chameleon is also an example. Okay, I'll write that down here, like polar bear and chameleon. Okay, so next is mimicry. So mimicry is basically just copying. So for example, if a snake, let's say a snake which is very venomous, has some sort of pattern, okay, which kind of indicates other people that this is it's like a dangerous animal. Okay, what happens is that another animal which is not as venomous copies, okay, that pattern, has a similar pattern to the snake which is venomous, so that no one attacks it thinking that it is a dangerous animal. Okay, so that's how mimicry works. And the next is structural adaptation to suit their lifestyle. Example of that would be this giraffe over here. So this giraffe has quite a long neck over here. Now the reason it has that is so that it can reach tall trees to eat leaves. Okay, that's pretty much its purpose. Looking into adaptive features in plants. Okay, so we have two types of plants. We have hydrophytes and we have xerophytes. Okay, hydrophytes and we have xerophytes. So hydrophytes are basically plants that are adapted to living in water. One thing you should always remember is that hydro basically means water. Anything that has hydra in the front, it's most likely related to water. Okay, so hydrophytes are adapted to living in water, and these are some of its features. So the first feature is it has wide and flat leaves. It has wide and flat leaves, which basically increases its surface area. Okay, like for example over here we have these leaves which are basically floating on water. Now what does this do is that it gives more sunlight to the leaves so that it can photosynthesize. Okay, it gets more sunlight due to a bigger surface area. Okay, so that's basically its reason why it has wide and flat leaves. And next, it has small roots. Okay, now they don't need much roots because they can absorb water directly from their leaves and stems. Okay, because they're already inside the water. So if they have roots, they will have excessive amount of water, which will ruin their cells, which will make the cells maybe burst in some occasions. Okay, so that's why they have very small roots. And next is the stomata, which is basically found on the upper side for efficient gas exchange. We know that stomata is basically, normally it's located on the underside of the leaf. Okay, over here on the underside. But since the leaf is already in water and the purpose of stomata is for gas exchange, it will be really hard for them to have gas exchange from here because there's water here. Okay, so that's why the stomata is located on top, so that they can have efficient gas exchange. Okay, now that's that. Okay, and let's look into xerophytes now. So xerophytes are basically plants adapted to survive in dry environments. Okay, so some of its features. Okay, so the first feature is that it has small leaves, which reduces surface area for evaporation. As you know, okay, cactuses. Okay, cactuses are an example of xerophytes, and we know that cactuses are usually located in deserts, and in deserts you don't really have much water. It's quite dehydrated over there. But how do the cactuses survive? Okay, it's because first of all they have small surface area. How do they have small surface area? These spines over here. Okay, these spikes? Yeah, these spikes reduces the surface area of the of the plant, so that less water is evaporated, and they can store as much water as possible. Okay, and next is extensive roots. So when cactuses are placed, okay, and if you ever dig deep enough, you will see that they have such long roots. Okay, that's because they are trying to have as much as water intake, so that they don't die due to lack of water. Okay, and then next is that they have thick waxy cuticle, okay, to prevent water loss. Okay, so as you can see over here, you can already tell by how it looks. They look very hard, and if you've ever touched a cactus before, you can see that they're very thick. They're very tough. You can't really bend them much. It's because they have thick waxy cuticle, which prevents water loss. In simple words, all leaves have cuticle, okay? But cactuses have thicker ones, so that less water is lost, okay? Because they want to survive, and for xerophytes, their main goal is that they don't lose much water, okay? And for hydrophytes, their goal is that they don't have too much water, okay? And next is sunken stomata, which is again to reduce water loss, and they have thick stems and leaf to store water. Okay, so basically all this, as you can tell, it's all related to water. Okay, water loss, storing water, it's all related to that. And hydrophytes is all related to not having excessive water intake. Okay, so one of the example over here is water lily, which is an example of hydrophytes, and obviously cactuses, example of xerophytes. Okay, so let's look into natural selection now. So natural selection, okay, it's basically something us humans are going through, a lot of animals and plants are going through. So it's basically when we gain adaptive features through competition with other population of the same species as us. Okay, so how do I put this? Okay, so for example, let's say in a forest there's a lot of monkeys, okay, but there's very less food. Okay, there's a lot of monkeys, okay, okay, but there's very less food. Okay, let's say this is an apple tree and you only have 2 apples, but there are 3 monkeys. What's gonna happen now is that they're gonna fight. They're gonna go through a competition, okay, and obviously the stronger one is gonna survive. So let's say this is a weak one. These 2 strong ones survive because they're more adapted to their environment. Okay, they survive, they mate, okay, and then they form another monkey, okay, which is also well adapted just like them, because they're passed on their allele to this new guy over here. Okay, so that's how natural selection really works, which means that people who survived previously, they pass on their survival skills to their children, okay, through their genes, to their alleles. Okay, so that's how natural selection works. And you know what, another example of natural selection is antibiotic resistance. Okay, now antibiotic resistance, okay, is very dangerous thing, to be honest. And a lot of our doctors, whenever we get sick, okay, our doctors, they give us antibiotics, okay, and every single time they give us that, they always tell us complete your dose. Now the reason to that is because of natural selection, okay. This is a really big crucial thing, because when you are sick, okay, when you have a bacterial infection, okay, your bacterias are inside of you, obviously, because it's bacterial infection, okay. So these bacterias, they reproduce very fast. They reproduce rapidly, like so fast, okay. So if we do not kill them quickly, okay, or if we stop killing them, for example, we take our antibiotic doses for about 2-3 days, and then we stop taking it afterwards, what happens is that now the bacteria that have survived, they're resistant to it. Now they're producing more and more and more, and then their kids, the bacteria's kids, okay, their offsprings, also know how to be resistant to your antibiotic. So after that, even if you take your antibiotic, it's not going to work on you anymore, because the kids are already adapted to it, okay. So that's how it works, okay. Like, okay, I'll put this like that. This is his bacteria. A lot of bacteria. And then you take antibiotics. After you take antibiotics, you kill the bacteria. But there's one bacteria left, okay? One bacteria left, which is still surviving. And then you stop taking your antibiotics. You did not complete your dose. This bacteria will reproduce more bacteria. But this bacteria, since it survived and it knows how antibiotic works, it's going to become resistant to it. So your antibiotic is going to become useless and it's not going to work anymore, because now there's a lot of them which are resistant to antibiotics, so it just won't work, okay. So that's just how natural selection works, okay. So yeah, if in your exam you're asked to describe how antibiotic resistance occurs, you would have to say everything that I've written down over here, okay, which is genetic variation within population, struggle for survival including competition for resources, greater chance of reproduction by individuals that are better adapted, survived individuals will pass on their alleles to the next generation, okay. So that's exactly what happens. Now, in a nutshell, adaptation is a process resulting from natural selection by which population becomes more suited to the environment over many generations. Okay, now let's look into selective or artificial breeding. So this is when humans choose individuals with desirable features. For example, let's say you want sweet strawberries, okay, because usually, at least where I live, every time I buy strawberries, they're quite sour. Let's say we want sweet ones, okay. Let's say we have strawberries over here. Okay, both of these strawberries, they're sweet. Okay, sweet. And now we want more sweet strawberries, okay, because we don't want the sour ones. So we breed them together. Breed them to produce more sweet strawberries. Okay, that's how it works. And let's say when you breed them, okay, let's say one of this turns out to be the imposter and it's not sweet, it's sour. We just basically just eliminate this, and then we use the rest of this to continue mating to produce more sweet strawberries. Okay, and then you continue doing that over time, you will get a huge batch of sweet strawberries. So that's how basically selective breeding works. It just means that humans choose what they want, okay, and then they breed them together so that they can have more of that batch, okay. So let's look into selective breeding in crop plants. Like, how does it work? How is it beneficial? So first thing, you can produce disease-resistant crops. You can produce disease-resistant food crops, okay? Which means that if there is a disease outbreak and the food crops have resistance towards it, they're immune towards it, so they won't be really affected, okay? And they would still grow healthily. That does not make sense. They will still grow healthy. I'm sorry for my English. Okay, next, you have increased crop yield, meaning that you'll have more quantity of whatever you're growing, and then adapted to changes in weather. So if one day the weather is not that nice, it's not that good, they will still be able to survive and grow healthy. And then improvement in taste, like for the strawberry example I gave you guys. Okay, next is selective breeding in domesticated animals. So domesticated animals, meaning that animals that come in our use, for example, cows, goats, sheep, chickens, okay? So cows and goats, they can produce lots of milk and meat for us. Chickens can lay large eggs. Sheep can give you good quality of wool, okay? So basically anything that can be beneficial of us, okay, for us, it's through artificial breeding, okay? Now, this is a table over here, okay, with the differences and similarities, differences between natural selection and artificial selection. First, natural selection obviously occurs naturally, meaning that humans not have to choose, okay, it just happens. And artificial selection is when humans choose the desirable features, and then you have results in development of population with features that are better adapted to their environment, okay? So they're better adapted. And then artificial is when it results in development of population with features that are useful to only humans and not necessarily to the individual, okay? And last but not the least, natural selection takes longer time for you to often see a difference in an animal and their adaptive features. However, in artificial selection, it takes less times because we are choosing ourselves what we want, and then we continue on doing that over and over again, which causes it to be more quicker than natural selection. I feel like this chapter is a bit boring and a bit confusing for some people, but I hope I was able to help you. That's pretty much it for this chapter. If you want me to go through any other chapter, please let me know in the comments. And if you like my video, please make sure to subscribe my channel and also hit the like button. And that's pretty much it. Goodbye.